Everyone talks about going to Mars. Elon Musk wants to colonize it. NASA is planning missions. Billions of dollars are being spent. But nobody is asking the real question. What happens after Mars? Because Mars is just next door. Mars is easy. Mars is a weekend trip compared to what comes next. The nearest star to our sun is Proxima Centauri, just 4.25 light-years away. That sounds close. It isn't. Light travels at 300,000 kilometers per second, the fastest thing in the universe. And even light takes 4 years and 3 months to get there. We have never built anything that moves at the speed of light. We never will. The laws of physics make it impossible for anything with mass to reach that speed. So let's talk about what we actually have. The Parker Solar Probe, the fastest human-made object ever built. At its peak, it travels at 700,000 kilometers per hour. That sounds incredible. It isn't enough. At that speed, traveling in a straight line to Proxima Centauri, it would take approximately 6,600 years to arrive. 6,600 years ago, humans had just invented writing. The Egyptian pyramids hadn't been built yet. The Roman Empire wouldn't exist for another 5,000 years. That is how far away the nearest star is. But wait, let's be generous. Let's say we build something faster, something we don't have yet. A fusion rocket, a laser sail, something that gets us to 1% of the speed of light. 1%. The trip would still take 425 years. No human lives 425 years. No government lasts 425 years. No institution on Earth has survived 425 years without completely transforming into something unrecognizable. You would launch the mission, and every single person involved would be dead long before it arrived. Let's push further. 10% of the speed of light. Theoretical. Enormously expensive. No existing technology comes close. 42 years. That's how long the trip takes. Possible for a human lifetime. Almost. But here's the problem nobody mentions. To accelerate a spacecraft large enough to carry humans to 10% of the speed of light, the energy required is equivalent to the entire world's electricity production for thousands of years. We don't have that energy. We don't have a way to generate it. We don't have a way to store it. And that's just getting there. You still have to slow down. Deceleration requires the same energy as acceleration. You need fuel for the return trip. You need life support for decades. You need a crew that can survive psychologically in complete isolation, further from Earth than any human has ever been, for their entire lives. The math doesn't work. Not now, not in 50 years, probably not in 100. This is why serious scientists don't talk about interstellar travel as a near-term possibility. They talk about it the way we talk about living forever. Theoretically possible, practically nowhere near. Now, you might be thinking, what about the rest of the galaxy? The Milky Way is 100,000 light-years across. At the speed of Parker Solar Probe, crossing our own galaxy would take 1.6 billion years. For context, 1.6 billion years ago, the most complex life on Earth was algae. The universe is not built for us to cross it. And here's the darkest part of the math. Even if we somehow solved all of these problems, even if we built a ship that could travel at half the speed of light, the nearest galaxy to ours is Andromeda, 2.5 million light-years away. The trip would take 5 million years at half light speed. 5 million years ago, our ancestors were walking on 2 legs for the first time. We are not trapped in our solar system because we aren't trying hard enough. We are trapped because the universe is almost incomprehensibly large, and we are almost incomprehensibly small. Space travel is not a lie. The achievements of NASA, SpaceX, and every space agency on Earth are extraordinary. But interstellar travel? Leaving our solar system and arriving somewhere else? The math says no, and the math doesn't care about our dreams.